Hi, in this video, we'll be talking about the string format operator. The string format operator is not the preferable way of formatting strings, but you can still find it in older code, so it's useful to know something about it. That said, keep using the format method and f-strings in your work. Let's start with the symbol of the string format operator. It's a % character. This method of formatting is also referred to as string interpolation because the operator interpolates other data types like integers, floating point numbers, and others into the formatted string. We use a format string, for example $s, inside the string as a placeholder and the % operator after the string to separate it from the values that are to be inserted in place of the placeholders. The format string is also referred to as the format symbol or format placeholder. The syntax of the string format is $, flags, width, precision, type. All these elements are optional except type. In the simplest case, we thus have the following syntax: %, type. And let's have a look at the simplest form first. The format string %s is used for strings. Lowercase s is used for the string type. The values may be literals or variables. Here's an example with a literal. Her name was %s, which means string, I think. And here we're separating the string from what should be inserted into the string. This is a literal string. In the output, the literal string Amanda will replace the placeholder. And here's an example with a variable. Name equals Chris. Print, and her husband's name was, here we have a string, and to be precise, this string over here, Chris. So the output is, and her husband's name was Chris. It also works with echoing. Country equals Austria. She's from a string over here, or Nigeria, I'm not sure. Here, this string country will be inserted. She's from Austria or Nigeria, I'm not sure. If there are more values to insert, we use tuples. The format string %d is used for integers. Have a look at the following example. Print I'm, here we have a string, and I'm, here we have an integer. S stands for string, D stands for integer, years old. And here we need two values, a string, Jack, and an integer, 64. So we use a tuple. And the output is, I'm Jack, and I'm 64 years old. Here we have another example. Let's define personal data as a tuple. And now we can use this tuple to format the string like so. My name is %s, so string. I'm %d, so integer. I live in another string, and I have another integer, kids. Now all these four values are stored in this personal data tuple. We have Mike 28, Amsterdam 3. So we can use the tuple like so. And the result is, my name is Mike, I'm 28, I live in Amsterdam, and I have 3 kids. Okay. Now, depending on the data type we need, we can use several format strings. You already know %s. This is used for strings. You also know %d. This is used for integers. We can also use %i for integers. Another one is %c. This is used for single characters. The characters may be given as one-letter strings. Have a look at this example. This starts with a letter, and here we have a format string, which should be replaced with a single letter, and here we have the letter. This starts with the letter A. We can also use integers corresponding to the values of the letters. So we can use it like so. Instead of A, we can type the value corresponding to A, which is 65. You can use the OR function to check what value corresponds to any character. And now what we get is the same. Fine. Then we have %o. This is used for octal integers. We also have %x, which is used for hexadecimal numbers. We can use small x or capital X. We use small x if we want the hexadecimal number to contain lowercase letters. We use capital X if we want the hexadecimal number to contain uppercase letters. Now, an example. We can define a number, for example, number equals 124. And now have a look at this. I will make it smaller so that we can see the whole code. Print decimal, now %d, octal, %o, this is for octal numbers, and now hexadecimal with small x and with capital X. We need 4 elements, which are all the same number actually, so we have to use number 4 times in the tuple. And the result is decimal 124. Now this is the octal representation of this number, and these two are the hexadecimal representations of this number. The first time over here we're using small letters because we used small x here. Now here in the format string we're using capital X, and also we get capital letters in the number. Fine. Now the next format string is %f, which is used for floats. Have a look. Weight equals 2. Well, actually 2 is an integer, but in our string it may be formatted as a float. It weighs exactly %f ounces. So this means that the number which will be inserted over here is a float number. And the result is it weighs exactly 2.00 and so on ounces. Fine. Then we have %e or %E. These are used for exponential notation with lowercase and uppercase e respectively. So let's have a look at the following example. Weight equals 0.0000412. Okay, and now we can use exponential notation. This should be done like so. Print. The weight of the objects is grams. Now this means a number in exponential notation. We're using small e here, So we'll get a small e in the output. Have a look. The weight of the object is 4.12 and so on, e minus 0.05 grams. Okay, we can also use capital E. So let's change this to capital E. And what we get is the same, but this time we get capital E over here. Then we have %G and %G. These are used if we want the shorter of %F and %E respectively. So here's our example. Numbers equals, let's use a tuple, 60 and 1 billion, 1, 2, 3, 1, 2, 3, 1, 2, 3, okay, 1 billion. And now, have a look at this. Print number. Here, we're using %G, and also here. Now we have two numbers, 60 and 1 billion. So if we used %E with 60, we would get something like this, 6.000000 E plus 01, which is longer than 60, which would be achieved by using %F. So %G uses the shortest possible notation. Well, let's have a look at the output first. Number 1, 60. Number 2, 1e plus 09. So the first number is represented as 60 because it's shorter than the one we saw before, 6.000000 plus 01. And %G chooses the shorter one. Now here we have 1 billion, but 1 billion is longer than this representation. This is why this representation is chosen, because it's shorter. Fine. Now we can also use capital G like so. Let's change this to capital G, here and here. And now what we get is, here we have the E, we use capitalized. That's the difference. We can also format strings in triple quotes. Have a look. Brothers equals Mike, Luke, Stephen. Text equals, we have triple quotes, and here we have the format strings. String, string, string. Fine. And now we can print it out. So print text % brothers. And we get the following result. These three placeholders or format strings are replaced by these three strings. In all the examples above, we were using just the basic format string syntax. But as we remember, we can put much more information about the string format into the placeholder. Let's have a look at an example with an integer number. Here's the basic form again. Print. They have an integer cars. Now the integer is 3. Nothing special here. And now we can add the width to the format string. We want the output number to be 4 characters wide. What we get is the number 3 preceded by 3 blanks, so 4 characters altogether. Have a look. Print. This is the width. And here we get the width, 4 characters, 1, 2, 3, 4. Okay. Let's now have a look at an example with a float number. Here we have a program saved to a file. By the way, the string to be printed may consist of just a format string, like here, just a format string. And here are the values to be inserted. Now, here is the output. So, what happened? The format string for all the numbers is %8.3f, which means the output should be 8 characters wide, out of which the last 3 characters are decimal places. So 8 characters wide with 3 decimal places. If the total width is less than 8, blanks are added on the left, like here, here, and here. If due to precision some of the decimal places must be cut off, the number is rounded, like in the first example here. The final width includes all the digits, the decimal point, and the blanks. So the string means a float number 8 characters wide with precision 3. There is, however, one thing to note. Although the decimal places are rounded within the precision set in the format string and the superfluous ones are trimmed, the integer part of the number, the one before the decimal point, is left intact, even if the width should exceed the width set in the placeholder. Have a look. Here you have 2 numbers. The first one is an integer, 2, which will be formatted as a float with width 4 and precision 1. Thus, 1 blank will be added at the beginning. Here's a blank, 2.0, because we need 4 places altogether. The width is 4. So 1, 2, 3, 4. Now, if the integer part takes up more than the number of characters specified in width, it will be maintained. The precision will be taken into consideration. Have a look. Print. And this number consists of more characters than can be fit into this width. So this part is maintained, the integer part is maintained, and the precision is taken into consideration, 1 decimal place. And now let's have a look at octal and hexadecimal numbers. Here's an example we were talking about a while ago. Octal and hexadecimal. Here's the output. Here we have just the basic format strings, %O, %X, and %X, used for octal and hexadecimal numbers. Now let's add width and precision. Here, width determines how many characters there should be altogether. If necessary, blanks will be added on the left. Precision determines how many characters should be used to output the number, and if necessary, zeros will be added. So here's the octal number, width 10, precision 6. This is what we get. Now, the hexadecimal number, again, width 10, precision 6. Okay? And the same with capital X. Fine. Now that we've seen examples with format strings, including width and precision, there's still one thing we can add to the placeholder. It's the flag. Flags are used immediately after the % sign. Here are the flags. The first flag is the hash symbol. If used with octal and hexadecimal numbers, the value is preceded by 0O, 0X, or 0X. For example, this is an octal number. Here we have the hash flag, and the output is preceded with 0O. How about hexadecimal numbers? Let's change O to small x, and now we get hexadecimal number preceded with 0x, or we can also use capital X, and we get this, O capital X. Now let's set the width to 5 characters and the precision to 3, so 5.3. Okay, that's why we get 3 characters 0, 3, 2 after this prefix. Or the same with capital X. Fine. And now the width is 10 characters and the precision is 6. So here we have blanks on the left and 6 characters after the prefix. Okay, another flag is 0. If used with numbers, the output will be padded with zeros on the left. Okay, here's an integer number with width 6. Without the flag, the output is padded with blanks. And with the flag, over here, 0, the output is padded with zeros. And here's an example with a float number without the flag and with the flag, padded with zeros. Fine. The next flag is the minus character. This flag's task is to left justify the string. So, have a look at this example. Here, we're using the minus sign to left justify the number. The width is 6, the precision is 2. So, within this available space, this is left justified. Then we can use the plus sign. It's also used as a flag. If it's used with a number, a sign character will precede the string. Have a look at this. Here we have a sign character. Okay. Another flag is a space. If used with a number, a blank will precede the string. Here's what it looks like without the space flag. And here's the same with a space flag. So we need to add a space over here. As you can see, a blank precedes the string. Now, string formatting doesn't have to be inside the print function. We can assign a formatted text to a variable and then pass the variable to the print function. Have a look. Text. This text is formatted, and then we can pass it to the print function. And it also works. Or even so, where the already formatted text is inserted into a placeholder. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.